alkane nomenclature. It is very easy to name any linear alkanes. For example, so in this case, this is a linear. So how many carbons are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons are there. Then we can call it is a octane. Then in this case, it is very simple. Suppose if it is a branch, then how we should name it. So that only we are going to discuss in this video. Let's go into the topic. The first step is we have to identify the longest chain. So please remember, the first step is identify the longest chain. Now take this is the example. So this is a branch alkane. Now we have to find the longest chain. How do we do? So we have to give the number from one terminal to other terminal. So there are so many terminals. So we have to check it. So let's give the numbering like 1, 2, 3, 4, 5, 6. If I give like this, I am getting xA. Okay. Let me take another terminal. So if I give like this 5, 6, 7, 8. If I give like this octane. So previously I get xA. Now I am getting octane. Let me check any other terminal. So let me give number from this one 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I give number like this, I am getting the longest chain is no name. So previously I get 6 number and 8. I didn't check some other thing. We have to check all the terminals. Okay. From this one I get no name. 9 carbon is no name. So this is the longest chain in this branched system. Okay. Now this is the no-name. Let me take some other example. Now, both are the same compound. I drawn it here. Let me give the number. I am giving the number like this. 1, 2, 3, 4, 5, 6, 7. Okay? I give like this. 1, 2, 3, 4. The same compound I am going to give in the other way. Let me give like this. 1, 2, 3, 4, 5, 6, 7. Observe it very closely. In the both cases, we are getting the longest chain is the 7. Okay. Now, which one we should choose? Now, the rule comes here in which the longest chain we are having maximum substituents. That we have to look into that. Which system we are having the maximum substituents? That means branching. Let me take this one. One like this system. That means this is one branching and this is the another branching. If I take this numbering pattern and I am getting this is one branching, this is another branching and this is another branching. Now here I am having 2 branches and here I am having 3 branches. So that means we should choose this system and this is the parent chain which is having the maximum branching. Okay. When we are having 2 equal parent chain which is having similar number of carbon atoms. This is the first rule. I am repeating it. First, we have to identify the longest chain. In some cases, we may get 1 or 2 patterns which may get equal numbering system. That means similar maximum length. Okay. So in that case, we have to choose the maximum branching one as a parent chain. The second step is we have to name the substituent. So this is the one we choose. I am written here. So this is the one methyl, and this is the group we are having called ethyl. This is methyl and this also methyl. Okay. So these are the substituents we named it. Now next we have to number the longest chain to get the least position. Now we should number it. I am going to give the number. Now let me give 1, 2, 3, 4, 5, 6, 7. So I may number by this way also. 1, 2, 3, 4, 5, 6. If I number in 2 different patterns, let me check here. So where the substituent comes here, this is in the second position we are having ethyl, and third we are having ethyl, and fourth we are having methyl. The positions are 2, 3 and 4. But here like this, you see position we are getting 4, 5 and 6. Then we have to compare. You see the first position itself 2, but here it is the 4. So that means this numbering system is not correct. So we have to choose this numbering system. Okay. So the third step is we have to number the longest chain in such a way the substituent get the least position. Okay. Now there is some other clause. Let me look into that. I give the number like 1, 2, 3, 4, 5, 7, 8. Okay. 3 and 6 I am getting. Suppose if I number like this 1, 2, 3, 4, 5, 6, 7, 8. Just see that in the both cases we are getting the positions 3 and 6. Here also 3 and 6. Now observe very closely. In this case we are having the ethyl at the 6th position and the ethyl here at the 3rd position. Then which one we should choose? So we should go here according to the alphabetical order. The E comes first. That means the lowest position should go for the first comes alphabet. So 3 for ethyl. So this could be the correct one, not this. Okay. So this is the step 3. Now next, the 4th. Now arrange the substituents in alphabetical order. Now we know that this is the 1, 3, 4, 5, 6, 7. So second and fourth position we are having methyl. So that means how we should write 2 for dimethyl. And the third position we are having ethyl. That means the E comes first. The ethyl substituent E comes first, then methyl. That means we have to give the preference for the ethyl. So we should write 3 ethyl, and 2 and 4 position we are having methyl. Both are having same position. That's why we should write 2 for dimethyl. The final is the parent chain. It is 7 carbon system. So it is heptane. You may ask, here the D comes first. Why we should not give? We should not give the alphabets for this multiplicities of the substituent. Okay, we should ignore like di, tri or tetra. So we should always give the preference substituents alphabets. Okay, so these are the 4 rules. I hope you understand the complete nomenclature of the alkane system. If you understand it, then rest will be very easy. On the basis of this alkane nomenclature, only we are going to give the other functional group nomenclature.